Hi, welcome back. In our previous lesson, we looked at the income and substitution effect of a change in interest rate in the life cycle model. Today, we'll be moving on to algebraic representation of present and future values. In our discussions of the intertemporal budget constraint represented in this figure here, we saw that the horizontal intercept is the present value of the individual's endowment, which is the most he could consume today given his present and future income. Now, the question here is, how can you decide whether the future benefits are worth the present cost? In today's lesson, we will attempt to use the concept of present and future values to address this question. Now, let's assume that you deposit $100 in the bank that yields an interest rate of 5% annually. At the end of year one, the amount that you are going to get is the principal, the interest that is earned. Now, this is going to be equal to the $100 that you invested plus 5% earned on that $100. So if we rewrite this, we are going to have 100 plus 0.05 multiplied by 100. This is going to be $105. If you invest $100 at 5% interest rate annually, at the end of the first year, the amount that you're going to have is $105. Now, if you let the money sit in the account for another year, the amount that you're going to have at the end of the second year is the principal from the first year plus the interest earned. This is 105 from the first year plus 0.05 times that 105. So at the end of the second year, the amount you invested is going to be worth $110.25. This can also be rewritten as this. What this simply means is that you earn this bit in the first year, you earn this bit in the second year, and that is multiplied by the initial principal that you invested. So this is also the same as 1 plus the interest rate raised to the power 2 times the principal you invested. Now the square here simply represents the fact that we are considering 2 years. If the money is put in the account for 3 years, then we are going to have 1 plus the interest rate raised to the power 3 times the initial principal that is invested. If we follow this approach, the more generally, if you invest $M for T number of years at an annual interest rate I%, then at the end of the T years, your money is going to be worth 1 plus the interest rate raised to the power T times M. This amount shows the future value of money that you invest in the present. So this is all that we have on the first part of our lesson on algebraic representation of present and future values. Our next lesson will be on part 2. If you enjoyed today's lesson, consider subscribing. Thank you.